Hello and welcome to the TES Secondary Maths Resource of the Week number 122 with me, Craig Barton. Now, I've often found, both in the world of maths resources and in the world of life in general, that the simpler things are often the best things. And this is such a simple idea, such a simple, straightforward resource, but the potential for richness and expansion is absolutely amazing. I really like it. So the resource is called Which Gives the Biggest Answer, and those of you who've been following my resource of the week for the last few years will know that this guy is one of my all-time favourite resource authors. Absolutely wonderful stuff from Owen134866, and I'll let you into a little secret. He's actually called Mike. So these resources, Which Gives the Biggest Answer, and it comprises of a PowerPoint and also an autograph file. Now, if you're immediately panicking, thinking I don't have autograph, don't you worry about that. As you'll see here, I've already got Desmos fired up to show you how you can use that. Excuse me. As an alternative. So let's have a look at the PowerPoint itself. Really straightforward. Which gives the biggest answer? It starts off with a little starter activity just to practice student skills of substitution, which is going to be a fundamental baseline skill that students need to succeed in this activity. So substituting x equals -2 into each of those expressions to see which gives the largest answer. Now, the choice of -2 is very important because it tees students up perfectly to think about what comes next. So here is the main activity, and essentially it all comprises of this slide. Which of these expressions gives the biggest answer? 3x plus 1, 1 minus x, x plus 1 all squared, and 2 to the power of x. And then there is Owen or Mike's little hint, is it always the case? Now, students who've done the starter activity will hopefully immediately start substituting values into there, and if you substitute, say, 10 in or 11 in, I think you'll probably find that 2 to the power of x by far gives you the biggest. But is that always the case? Where's your cut-off point? What about for smaller numbers of x? What about decimal numbers of x? What about negative numbers of x? Now, depending on the group that you've got, either they may suggest or you may have to lead them down the path of thinking about the graphs of each of those functions. So straight away we're moving from substitution into graph plotting and using tables of values and so on. And those of you familiar with the new spec GCSE will know that 2 to the power of x, exponential graphs like this, are now quite a key part of this new GCSE. So, as I say, it's up to you how you guide them to it, how you get to the point where we're thinking about graphs, but then it's time, I believe, to turn to Desmos or Autograph or whatever. So I just googled Desmos, those of you not familiar with it. I'd always advise you go onto the little spanner tool and go into projector mode. Even if I'm using just on my laptop, I go for that. And then let's start banging in some expressions. Y equals 3x plus 1. So of course we'd have asked the kids how to draw y equals 3x plus 1, what are sensible points to plot and so on before we bang it up there. And we get something like that. I'll just get that keyboard down a little bit. And then what about the next one? Y equals 1 minus x. Y equals 1 minus x. And if we pause there straight away, then we can discuss which function gives us the highest value when we substitute values of x in. Well, we can see now it depends. If we are substituting an x value of 0 in, it doesn't really matter, both of them give us 1. However, anything greater than 1, this red function is going to be bigger. Anything less than 1, this blue function is going to be bigger. So already we're starting to see that it matters which value of x we put in, and we can talk about how we would find this value of 0, how we would find this key value of 0 without plotting the actual graphs themselves. And then what happens if we bring another one into the mix? And again, we can have a rich discussion about what this graph actually looks like. X plus 1 all squared. How does it relate to the graph of x squared, for example? X plus 1, close your brackets. And I love Desmos. It's so intuitive how you put things into the power of 2. And now we get this. Now this looks a bit congested, but you can do a nice little zoom function here. And I could just project that on the board and say, okay, tell me now, which function gives me the highest value of x, highest value when I substitute x in. And again, we can see it's not that simple anymore because this green function seems to be kind of taken over, but where does it take over? And again, we can use Desmos to help us find points of intersection. We can link that into algebraic ways of finding points of intersection, and so on. And then and what about when we're going negative, which gives us the highest values? It's still the blue, or is it now the green as well? And what about this range in the middle, which gives us the highest value? And by the time we've plotted our kind of fourth one into the mix, 2 to the power of x, we end up with a graph that looks like this, and we're getting into lovely areas areas of maths. Firstly, we can discuss about why on earth do they all seem to be crossing the y-axis there. Why when we substitute x equals 0 into all of them do we get 1 out? And then we can get into inequalities. Can you start to represent these different regions here to tell me put in order which function gives me the highest value when I substitute x into it. Loads of stuff we can do. And then, I mean, we can do all the crossing points. We can take a little trip up here. What's that crossing point? How the flipping heck are we going to work that one out? Do these two lines have a cross? How do you know? How do you know they don't? And so on. And then we've not even got into the realms of possibility for asking students to come up with their own versions of this question. So can they create 4 functions that all cross in one single point? And then can they order them for different values of x and so on? So all from this simple beginning, we get loads and loads and loads of different potential questions. And we can even go into the realms of proof and so on. And basically all students need to be able to do to be able to access the core part of this is to be able to substitute numbers into expressions. And then it's up to you and up to the class where you take it. So I just thought that was an absolutely lovely, lovely, lovely resource. So there it is, which gives the biggest answer. And I shall be back with a fresh resource of the week next week. Take care and bye for now.